Last time we got the robot into the simulator. It looks great, but right now it's just a 3D puppet. To make it a robot, we need a nervous system. In this industry, that nervous system is ROS2. Most people see a wall of code and get intimidated. Today, I'm going to show you how to wiretap your robot's brain. We're going to use senior engineer commands to see exactly what every motor and sensor is whispering to the CPU. Imagine this robot dog is like a human body. It has a brain, muscles, and senses. In the world of robotics, we use ROS2 as the nervous system that connects all these parts. Instead of one giant brain program, ROS2 breaks the robot's mind into small specialized workers called nodes. Each node is doing some special task. Some of the nodes are for sensing, some is for actuating, and so on and so forth. So as you can see in this image here, I try to make a simple figure and diagram of what we're going to do in this session and what we're going to learn. The circles in this diagram are nodes. Each node has one job, only one. One node might only care about reading the camera. For example, these are the eyes. Another node only cares about moving the legs. These are the muscles. The benefit of this is if, for example, if the camera node crashes, the leg node can still keep the robot standing. It's modular and safe. Nodes are like employees in a company. The accountant doesn't need to know how the janitor works. They just need to send the right paperwork to each other. Then we have topics. This is the constant stream of data. Look at these arrows connecting different nodes. The most common way they talk is through broadcasting, through topics. A topic is like a radio station. One node publishes or broadcasts information as a radio station, and any other node can subscribe or listen to it. This is for data that never stops, like heartbeat or video feed or whatever sensory information. For example, one topic in the dog robot we have here is constantly shouting. The back left knee is at 45 degrees. It is at 50 degrees. So on and so forth. It goes forever. It's just doing its job, and it's broadcasting the joint's states at each moment, at each sampling rate. Then we have services. Let me show you here. Then we have services. Sometimes we don't need a constant stream. We just need a quick answer. This is the service. This is a request-response pattern. A node asks a question, a request, and waits for the answer, the response. You might call a service to reset odometry. You send a request, reset the position to 0, and the node replies done. This is it. Then we have the actions, the long-term missions. For example, we want the dog to go a certain location. Unlike a service, an action gives us a feedback while it is working on the task or action that we gave to it. We can also cancel it if something goes wrong middle way. For example, the goal, this is an action. The goal is walk to the kitchen. While the robot is walking towards the kitchen, the robot sends feedback. I am 2 meters away. I'm 1 meter away. For example, if a cat jumps in front of it, we can say stop, cancel, stop here immediately, and it does. Then we have the parameters. These are kind of robot's personality and capabilities. And these are not shown in this table, but for example, we can set different settings for it, like the max speed, the camera resolution, and so on and so forth. But then let's see how this works in reality. We were going to jump into the code, the command window, and see how this works. So let me clear up everything here and start from scratch. And also this one, let's clear this. So in this session, we're going to work on these specific commands and see what they're going to do. So these commands, if I run them, this is all the things that I explained so far, and we're going to see how they can work. Okay, I will share these commands with you guys. If anyone wants to follow with me, you can directly copy and use them. With this command, we give the ROS2 launch Gazebo sim launch.py. This is just running the code, and let's do it. So if we run this, we will, let me put it here out of the way, and okay, and now what we can do. So let me bring this one here, and then we can look at the okay. So let's start with the nodes, and so as you can see, our robot is loaded and ready to go here. Let me rotate it a bit to see what it's doing better. Okay, so we're ready to go, and let's see. Okay, well, let's start with the nodes, and then we don't need this for now. Let's start with the node and see a list of nodes that are implemented in this model. I will do it in another window. Yeah, so as you can see, we have different nodes. This is the list of the nodes that are implemented here. For example, one node is doing odometry, then we have planar server, RVs, and AMCL, so on and so forth, CMDI well pop. So let's see what we can do with this. And as you can see here, we have robot 1 here. As the model are able to implement more than one robot, more than one dog in the same simulation, we have to know which robot we're sending the commands or reading the sensory information from. So since we only have one robot here, everything is robot 1. Okay. Let's see in another window the list of topics we have. So I will use ROS2. Now we're going to send a topic and list. We want a list of different topics that we can use and exists out there. So again, we have the robot1, CMD well, and so on and so forth. So we can do this for all the actions, services, topics, and nodes and get a list of them. Let's see, for example, let's clear this again. Oops. Clear. Let's see what we can do with this. So we want to, as I said, the topics are radio stations. We either can publish or broadcast some news or commands or something, or listen to them. So for example, here, first, okay, let me run the teleopt. Let's get robot walking. Okay, so now we can control the robot from here. It's standing right now. So now we want to listen to a topic and see what's going on. So these are the different topics. What we can do is ROS2 topic echo. Echo is just printing the values that are getting received, and the topic's name. So for example, robot 1. As I said, we have to know where we want to listen, or where we want to send the commands to. And then we want to, for example, let's say we want to know the joint states. Joint states. Okay, so here, as you can see, it's the radio station is streaming data again and again over time as it samples, and you can see the position of the joints, the velocity and effort, and the name of the joints: left LF hip joint, LF lower leg joint, and so on and so forth. And also the timing, stamp and nanosecond, whatever it is. So for example, if we send a command, I will come to this window, use my keyboard to have the dog start walking, for example. Now that it started working, so let me send a command to it to just rotate and not get out of sight, so we can see it all the way. So now you can see in this window the velocity of each joint that is changing over time, its position is changing. And if I use K, keyboard K, on this window, this terminal, it stops, and at the same time the velocity gets very low. You may not see it, but let me break this part. Okay, so as you can see it's 4.5 e minus 17, so that's almost 0. So as the robot has stopped and the robot and its joints are not moving anymore, we have almost zero values here. But if we start walking or doing something, we will get new values from here. And another interesting command that we can use, for example, is to see Let me get the list again. So we want to know, for example, what is the sampling frequency of this joint state update. So we write ROS2 HZ, which stands for Hertz. We don't need echo here. We want to know this one's sampling frequency. Oh, I forgot topic. Okay, now we can see average rate is at 86 something hertz, the minimum, maximum, standard deviation, and window, so on and so forth. So this is one command that might be useful. And then, for example, we can look at let's look at other things, other topics that exist out here, and let's get some information about this robot velocity. So if you want some information on a certain topic, we write ROS2 topic info about that topic and then the topic's name. So it says the type is quadruped messages / message / robot velocity. So publisher count 1, subscription count 3. So 3 nodes are listening to it and 1 node is publishing it. The same goes for other things, so we can list, for example, see a list of services with this command. So we can also use these commands as different services. For example, robot1 quadruped controller list parameters or set parameters and or get parameters. These are different services. As I explained here, the services are when we don't need a stream of data and we only need a request and response. Get map, here is the map. Do this, okay, and that's it. Then we have the actions, which is a longer run, and we can have feedback and updates while we're doing these commands. And let's get, for example, this one. Okay, and one important thing, when you don't know which parameters or which commands you can send, and you have written to some part, if you double tap on tab, it gives you different commands that you can use, for example, verbose or whatever. Boolean value is false. So we wanted to get the value of quadruped controller verbose parameter, and its value is false. So that's it. So we will do different things with these, with getting the parameters, setting the parameters in the code, and then using. But so far we're just getting some introduction on what these are actually for. So let me stop the robot here and break this. I'm going to now publish a topic. So far we listened to different topics when we wanted, for example, joint variables. Now we're going to publish one and see how the model, the dog, will react to it. So what I have chosen to do is, let me first show you again a list of topics. ROS2 topic list. I'm going to use geometry messages or CMD well. Robot 1 CMD well. Okay, here we will go use this topic, and instead of listening to it, we will publish a new one. And let me just copy paste this command here. So ROS2 topic pub stands for publish only once, and to which topic, CMD well and this. And then what we need to publish, this is the message. So we want it to do this thing. As you can infer from the name, we're sending a velocity command to have the robot start walking or doing a certain thing. Let me bring this guy again here in the middle. So for example, this is the message. I will show you how you can publish in different topics. So each topic has a certain structure that you have to use to send that topic so that the other nodes can understand it, or understand what you're saying it. So in this topic, it is designed so to have a linear velocity and angular velocity. We will, let me just make it 0, the angular velocity. So right now I want the robot to go directly forward in X direction. So let's see what happens. If I hit enter, okay, we are sending, I think we're sending it to wrong direction because it's a multi-robot. We have to define which robot we want to send the command to. Did I? Robot 1 and again. Try it again. What is this? I had a typo here. And this was also, I think, not correct. Okay, so you can see that the robot has started working. So it's walking forward with this velocity. So let me. So we just gave it one command and it started going forwards to, I don't know where it's going. Let's call it back, and how we will, for example, I will give minus 1.5 in X direction, and as you can see here, it started coming back in minus X direction. It is coming back like that. Let's stop it with sending a 0 command. And okay, we have it here, stopped here. So this is the command ROS2. What we want from ROS2, we want to do something with topic, and what we want to do with the topic, we're going to publish in a topic. How many times? Only once. And which topic we want to send the commands is robot1cmd well. We are sending velocity commands and to this, and the specific command should look like this. And let's try, for example, having it walk on Y direction, see if it can do that or not. So I want it to move in the Y direction with a velocity of 0.5. Obviously it cannot go in the Z direction, so let's see if it can move. So it published. Okay, nice. So he can also walk in the Y direction as well. Let me have it stopped. And then let's try sending angular velocity. So of course, so X is aligned with its body towards front of the robot, and the Y is aligned perpendicular to it and parallel with the ground. So we want it to turn to left or right. So we will have the Z-axis from the ground to going upwards. So we need to send a velocity command, angular velocity command, around Z direction. Let's see. Okay. So now it is only rotating on its own Z-axis, around its own Z-axis. But what we can do, we can have it rotate on its own Z-axis and go forwards as well. So it will walk in kind of circular pattern. Let's see if it can do that. Okay, so it walks and at the same time it rotates, so it's following a semicircular pattern. And that's it. Let's stop it here for a moment. So let's use this command to... Okay, so when I said that we have a certain model that we have to communicate and it is defined in a certain channel or topic, I was talking about this. So as you can see, we sent a geometry messages slash message slash twist, and we send this specific message in this channel. So how can we know, since we have downloaded this, how can we know what kind of structure we have to use for it? So we can use this command, ROS2 interface show geometry messages, the same one we used here. We need some information about this specific message in that topic and its structure. It exactly says that you have to send a 3D vector with linear values and type of float 64 for x, y, z direction, and then another 3D vector with angular velocities. So this is how we can find out how we can use different messages, how we can send different messages to the robot. And now let me check this one, for example. Okay, one important, very important and instructive way to understand the robot, this specific robot that we have, is to use this command, which opens up a window with all different commands and topics and how they're connected to each other. So here we have robot1 ROS GZ bridge. And then we have these different nodes. These circles or whatever they are different nodes. So for example, this node, the same that we were able to see here, ROS2 node list. So these are the nodes. So for example, we have robot1 AMCL. You can also see it here, robot1 AMCL and CMD well pub. You can see CMD well pub and the other different nodes. And if I use a list of topics, so these are the arrows in this RQT graph, and these are this. For example, robot velocity or robot1 robot velocity. It goes to this node, robot1 quadruped control, and then it has different broadcasting channels or topics, robot1 joint group controller commands, foot contact, and others, which goes to robot1 odometry, and so on and so forth. This is a very informative graph of every node and every topic that we can use them. We can have them with, we can sort them with nodes only, topics only, or have the actions here, TFs, images, or whatever. We need it to leave topics, did things. These are not related to us anymore, so we can close this for now. And let's So we looked at the topics, the nodes, getting the parameters, and getting the listening to the topics, and broadcasting topic, and having the robot work. One important thing is also informative is ROS2 run TF2 tools. This command gives us okay, we have it here. When I use this, it creates a PDF. Let me see. It won't be able to. Not this one. Here we can go to Ubuntu, Home. Here goes Sam, and now we have this PDF here. So it gives frame results recorded at the time, the broadcaster, default authority, average rate, buffer length. It gives certain data about our odometry or something like this. Let me see, for example, if this frame does not exist. So let's keep this for now. Then we have controllers. We can take a look at the controllers and see what controllers are implemented in this model, which for services controller manager, list controllers to become available. We have not activated it. And that's it. So we will deal with this issue later in the next session, and in the next session I'm going to try to define certain behaviors, certain controllers, or certain actions in code and have them controlling the robot instead of doing manually everything from the command line window, and see how it goes. So far we dealt with the installation of the ROS2 Gazebo, getting this model and launching it, and doing certain tasks, getting very basics and concepts actually of the ROS2. Then we were going more into details of how we can use these commands to actually do something useful with our dog, and have them have it do certain things and implement interesting behavior from it. If you have not seen the previous video, I will put the link down below so you can go watch it. There we installed Gemini CLI and WSL and asked it actually to install everything, dependencies, ROS2, Gazebo, and used it to install everything and their dependencies and run the model. Now in this session we covered this stuff to control the robot and get used to very basics and concepts, and in the next session we'll go into more details. So subscribe and put any comments there if you want me to do a certain thing, or if you have any questions on it. See you next session.